So last class we had some outside and some inside transformations. I went and I can't remember if in our class if we wrote outside and inside. If we did not, we should add that in. Okay. But anything outside, I kind of put in a box. The new one's at the bottom. Anything outside, we're going up or down. We could be going up, we could be going down. When there was a negative number, a -1 on the outside, that was a reflection up or down. Then if it was on the inside of the function, that affected left or right. That is always the same. If it's on the outside, up or down. If it's on the inside, left or right. So what we're learning new today is we have a number being multiplied on the outside of the function. Today what's new is a number being multiplied on the outside of the function. So if I have a number being multiplied on the outside, is that going to be up or down or left and right? Up or down, because everything on the outside is an up and down vertical thing. Okay. I'm saying up and down, but really I'm going to use the words vertical. Thank you. Thank you. So vertical, if we have anything on the outside, it's vertical. This is going to be an up and down thing, vertical. We're multiplying by a number. This is going to give us either a stretch or a shrink. It's going to give us either a stretch or a shrink. This is where we're going to figure it out. So once you have that copied down so far, go ahead and open up your graphing calculator. Go to y equals. And let's start with the parent function of absolute value. Absolute value of x. So everybody make your y1 absolute value of x. Know what? Get your phone, switch me for calculator. Okay, now we are multiplying numbers on the outside. So I'm going to give you a moment to choose whatever number you want, and you're going to do more than one. And remember, to get to absolute value, we do math, arrow over to number, absolute value, x. Now I want you to pick more than just the one that I did. Let me just make sure. Sierra, do you have a calculator? No. Okay. That's fine. I was going to say, you might have to ask Marcus for help if you don't know how to find the buttons, because it's a different calculator. Marcus, will you assist? I can't.
Thank you.
Zoom 6. Zoom 6. Okay, so you should have multiple things going on. I only did one so far, so I'll just, what numbers did you guys put? Throw out a number. What? 5? Okay. 7? All right, I'll do that one too. 7. Value x. What was the other one? Oh, was it? That's all I heard? Nobody else did any numbers.
I did 3.
You did 3? What'd you do? 4. Okay, those are pretty much the same. So nobody got really creative is what I'm saying. All right, so let me graph these. And they graphed in order. My original function, my parent function is blue up here. So every single one of these is getting closer to being more vertical. All right, we got to think it's on the outside. We have to think vertical. All right. So for this one, is this like I pulled your hands up or pushed your hands out? Yeah, this is a vertical stretch. Okay. We need to figure out how we can make a vertical shrink because every single number that you all yelled out made it rise up faster. I need it to not rise as fast. Negative. Okay, so if I do -2, it doesn't matter what number. I'm just going to do -2 because I already had a 2. Absolute value. No. X. What did the negative do? It reflected it. Sure. Okay. Kevin, you're leading, so bring in my calculator. Okay. So yeah, the green one up there, that's the -2. So the negative is not going to make it shrink. The negative is going to flip it completely over. So it's not negative. Who else has an idea? You want to be more specific because there's a lot of fractions. You want to give me a fraction? Half? Okay. So to do fractions, you can either, if you have the older calculator, I'll do this one by the older calculator. You can just do like a half in parentheses, 1 divided by 2. If you have the older calculator, I'll do another fraction, the newer calculator way. I mean, once I get this part here. So here's 1/2. How about we do, oops, give me another fraction. I don't know. 1/4. Okay. So alpha y equals enter is how you get those actual fraction bars like that. Okay, so we're trying a 1/2 and a 1/4. I've got the other ones graphed still because it's pretty. And then that is correct. So we're getting wider and wider when we chose the 1/2 and the 1/4. So what we need to do is summarize by looking at an equation how I know if it's going to be a vertical stretch where I'm pulling your hands up or a vertical shrink where I'm pushing your hands down. We need to be able to write that. It has to do with that value for A. If it's a whole number, it's a stretch. Okay, so I'm going to play devil's advocate. You know what that is? Do you know what devil's advocate is? I'm going to prove you wrong, basically. So what I'm going to do is I'm going to choose the whole number of 1, absolute value, X. So if I do 1 absolute value X, that will be like a red color, like a maroon color. What that did is it completely went on top of my blue one because absolute value of X and 1 absolute value of X are exactly the same. So I'm going to be more specific than just it being a whole number. Can somebody help that out? Oh, we're going to sit here all day. Okay. I see. I don't know what. Yeah. The word whole number is where I'm struggling. Let me give you a fraction that proves that statement wrong. Oops, I just hit the wrong thing though. Hold on a second. Alpha y equals, I'm going to give you a fraction. I'm going to do 10 thirds. I don't know. 10 over 3. That is a fraction. That is not a whole number. So this one is a stretch. That's the maroon colored one. It's not the bright red. It's the one between or in between the black and the bright red. That's the one I just did. 10 thirds is in there. So that fraction was also a stretch. So I don't want to say that it's a whole number. But I liked how she said greater than 1. What do you think, McKendrick? If it's greater than 1. And we'll come back to the, you said them backwards though. But if it's greater than 1, it's a what? Stretch, right? That 100%, that's what I'm looking for. If A is greater than 1, we're going to have a vertical stretch. If we multiply by something that's bigger than 1, it gets bigger. Now, McKendrick also went on. He said, if it's less than 1, then it's going to be a vertical shrink, and that's not always true. You're partially correct. Some numbers less than 1 will be a vertical shrink because we had 1/4 and we had 1/2. But do you remember when I made it negative? When I made it -2 or anything. Right, it was a reflection. They're -3. So we can't just say less than, so there's my -3. We can't just say less than 1 because as soon as it turns negative, that's a completely different thing. That's a reflection. So we're looking at just that value being less than 1, but also what? Greater than 0. And if it is 0, then we wouldn't have a V shape at all. So it's got to be greater than 0. Whoever said that, good job. So we're looking at if it's between 0 and 1, it's a vertical shrink. If it is greater than 1, it is a vertical stretch. Now, this is the same for every single function. Every single function. So it does not only work on V shapes, on absolute value. It works on every function. Go back and just clear out all of this. Clear. Let's do square root of x. And then let's put a number on the outside of the square root of x. I'm going to pick a number that is greater than 1. And then I'm going to do a number that is in between 0 and 1. So how about 0.1 square root x? So I've got, according to the rules, I have a vertical stretch and a vertical shrink. And I'll graph it in just a second, just letting people copy down what I had too. So I'm picking one vertical stretch. I mean, you don't have to pick the same numbers as me, but I'm picking one vertical stretch, one vertical shrink, so that we can see how, even though we start with a different shape, that vertical shrink is fairly vertical. We started with a different shape. My blue one is the parent function. You can see the red one is raised up higher. The black one is the opposite. It's much, much lower, but it still has that same shape. Okay. So that's vertical. So now I'm going to put a value that we're going to multiply by, but it's going to be on the inside of the function this time. So now I've got b times x. That's on the inside of the function. Now from all of our past lists, all the past lists that we had, every single thing that we had was inside. They were all where? All the inside stuff, where is it? No, not vertical. Look at any of the ones that say inside. I highlighted them in like ugly yellow. Horizontal. Every single inside thing up there so far is horizontal. This one's not going to be any different. It's going to be a horizontal stretch or shrink. Okay, so when we multiply by a number on the inside, it's going to be horizontal. And it's either going to be a stretch or a shrink. Before we use our calculator to figure it out, I want to remind you about when we did adding a number, like right here, when we did adding a number, and use my cursor right here, when we did adding a number, when we added it, it actually went to the left. And when we subtracted a number, it went to the right. Do you remember doing horizontal? It was kind of opposite of what you'd think, like not common sense. Okay. Okay, so let's go to our calculator. Let's start with x squared for our original parent function. So clear out all those other ones. And we're going to do x squared. So to put something on the inside of x squared, you're going to need parentheses. Type it on your calculator. You're going to need parentheses. And I will let you choose your own numbers. I'm going to pick a 2 for my example. But you're going to do 2x on the inside and then put the squared on the outside of the parentheses. You choose a few different numbers, because we need to figure out what makes it stretch and what makes it shrink. And then keep in mind that these are horizontal. Birdie, what's the number you're choosing?
5.
Okay. Oops. Bless you. Sophia, what's the number you chose?
8.
Anybody else have a more unique? What did you choose?
It's not unique.
What is it?
It was baby number 9.
Yeah, it's not unique. Anybody have something unique?
0.5.
0.5? 17? I'm not going to do 17, but that's more unique. I'll do 0.5. Because nobody else picked a decimal, right? Well, nobody so far. Anybody else pick one? What'd you pick? 2.5? Oh, I'm sorry. I can't hear you, hon. Oh, you also picked 0.5 is what you were saying. Okay. Should we do 2.5? All right, why not? I already typed it in. I mean, you don't have to type that one in. You can just watch it. But any others I should try? 0.75? Okay. All right, I'll do those. So we're not going to do negatives right now because that just makes it a reflection. And we're not talking about reflections. We're just talking about stretching and shrinking. Okay, so these are in order of whatever I typed them in, but the blue one is the parent function. Okay, so I can actually jump on the graphs, and when oh my God, Jackson, do you want to stand? Okay. When I go on the graphs, you can, at the top, you can see which, graph. At the top, you can see which graph I'm on, like, see, I can jump between the graphs so we can see which color is what. So my blue one is the parent function. See if I can get back to the blue one. No. So the blue one's the parent function. So this maroon colored one is 0.75. Is the maroon one inside of that parent function or outside of the parent function? Right. So we need to think about horizontal. So you remember I grabbed your arms and I pulled them horizontally out, or I pushed them horizontally in. So which is 0.75? Is that me pulling it out or pushing it in? That's pulling it out. 0.75 is a stretch horizontally. Okay, what about, oh, there's my original one. 2, that one's bright red. 2, is that me pulling arms out or pushing it in? Look at the bright red one compared to blue. That's pushing it in. That's a shrink. 2 is a shrink. 0.75 is a stretch. 5 is a shrink. 8 is a shrink. 0.5 is a stretch out because we're talking about horizontal rather than vertical. So when we describe these, huh? Say it again. Is it the one? It's the same rule as in we're going to have if A is greater than 1, or it's not A though, it's a B this time, sorry. It's the same rule that we're going to have B is greater than 1, except when I chose B greater than 1, when I had 2 and 5 and 8, those were horizontally shrinking it. So this is opposite of what you would think. The bigger numbers actually make a horizontal shrink. All right. So then if B is between 0 and 1, that's a horizontal stretch. So these are kind of opposite of what like common sense would tell us. Everything that we did horizontally on here kind of went opposite of what like common sense normally tells us. So we want to think vertical is like common sense. If it multiplied by 6, it gets bigger. It's a stretch. But horizontal, if there's a 6 in it, it's actually going to get smaller. It's a shrink. Okay. So once you have these down, I have a worksheet which I'm passing out right now. And we're going to finish our notes and just do some of these from the worksheet. Were you supposed to? No, I'm sorry. What question are you asking?
It was like a worksheet that we had.
Yeah. Yeah. Right. So you know how to submit it? Like scan it? Oops. So when I'm done with the video, make sure there's 3 there. I feel like that's 4.
Yeah.
Okay, did I skip anyone? Did I give everybody? Okay. Everybody got one? Yeah? Okay, so we're going to kind of go through the process of what you need to do to figure these out. Now, we wrote notes. You are allowed to use your notes when you do your assignment. You're just not going to see mine because it's like too much going back and forth. But you have your notes on a separate piece of paper right next to the assignment paper. So I'm going to look at question number 1. The first thing we're going to do is we're going to say, what's my parent function look like? It's the absolute value. It's the V, right? It's going to go through the center of the top two quadrants. That was kind of wobbly. There we go. All right, so now we're going to look and we're going to say there is a 3 being multiplied. And if I'm multiplying by a number, we have to determine if it's outside or inside. Okay, so this one's outside because you look at the bars and it's not inside of the bars. So that's outside. And then we talked about anything outside is always vertical. Okay, that's up and down kind of thing. Now, when we did vertical, and you can look at your notes, if I have 3, 3 is greater than 1. So is that a stretch or a shrink? It's a stretch. So if you don't remember which way a stretch goes, just imagine, okay, Miss Criswell is going to grab my hands and vertically she's going to stretch them. Okay, so that's going to make it kind of rise faster. And my V shape got stretched vertically. Okay, so question 2. It's going to start out with x squared. What shape does x squared make? The U. It's called quadratic. So we've got our U. I'm going to look at the 1/4. And is the 1/4 outside or inside before you yell out the answer? Is the 1/4 being squared?
No.
It is not. Remember when we when we did the inside stuff, I had to have parentheses. So in order for it to be inside, it's got to have parentheses. This one does not. So this is outside. So if it's outside, vertical, good. And then that 1/4 is somewhere between 0 and 1. So is it a stretch or a shrink? And you have your notes to help you if you forget. So then shrink, if I take your hands and I vertically shrink them, that means I'm pushing down. They're not rising up as fast. They're less vertical. So it ends up looking wider. All right, question 3. I'm going to do this one because there's a negative sign in this one. So we're going to start with our absolute value. And the negative and the 2 are both on the outside. So they're both outside. So they're both vertical. But I keep saying both because the negative sign and the 2 are 2 different things. What's the negative do? All right, I'm going to use the word reflect because that's the word we're going to start using. But since it's vertical, we're going to reflect it down. And then we need to figure out 2. Is 2 greater than 1? Yeah, so that's a vertical stretch. So with a vertical stretch, you imagine me taking your hands and pulling them up vertically. So it kind of looks skinnier, but we also have to flip it down, reflect it. So it's going to be skinnier than the original, but it's reflected down. And there's no numbers here, so it doesn't have to be perfect. If you're getting stuck and you're feeling like, well, I'm losing my notes, but I'm not sure, you can use your graphing calculator to check that you're doing it right. Please don't just type everything in the calculator and copy it down because then you won't learn it. This is about you learning it. You have to kind of trial and error things. Let's look at number 7. So number 7 is quadratic. It's squared. So we've got the U shape. Where is 2 located? And we know that this is inside because of the parentheses, and then the squared is outside the parentheses. So 2 is on the inside of that. All right, so that's going to be horizontal. And you say 2 is greater than 1. Is that a horizontal stretch or a horizontal shrink? So if you're not sure, we wrote down on our paper, when it's greater than 1, that's a horizontal shrink. Okay. So this is going to shrink horizontally. That means it's getting less horizontal. That means it's going to go like in, like I'm pushing your hands in. It looks like it's going up more, but I'm pushing your hands in. Like how we get there is different. Okay. And then on the back, I'll show you how to do this real fast. So what you're going to want to do, so if on the back, all of the dashed ones are the parent function. So the dashed one is my blue one. That's the parent function. The one that is solid is changed somehow. All of these are going to be vertical stretch or shrink or horizontal stretch or shrink. You cannot look at it and know without actually looking at what the ordered pairs are. So you're going to want to write down the ordered pairs first.
We do have a couple afternoon announcements.
So write down the ordered pairs while the announcements are going.
Don't forget to scan that QR code and buy those tickets. Remember, if you're bringing someone not from this school,
I know these ordered pairs, so I'm writing them fast.
all forms need to be turned in before you attend the dance.
But my dashed ones
At Lights, Camera, Coco. Once again, congratulations.
are -3.9, -2.4, -1.1. It's you're just squaring each number and multiplying it by itself.
Students, don't forget about voting for senior royalty by scanning the QR code.
Great. Also, just an update, the Women in does conclude the afternoon announcements. Have a great afternoon, and remember, as always, go Firebirds.
Okay, so I'm writing these fast because I know the ordered pairs already. What you're going to do is you're going to compare your X's, compare and contrast your X's and your Y's. So I look, in mine are in color, so I'm going to talk color, but yours are dashed or solid. I'm looking at the dashed blue X's and the solid red X's. What can you do what can you tell me about those X's? Both columns of X.
They're the same.
They're the same. Thank you. They're the same. What about the Y's? They're different. So what's changing here is the Y's. This is a vertical something. Second question. Did the Y's get bigger or smaller from the dashed to the solid? They got smaller. This is a vertical shrink. How do you know is the next part. I'm writing Y because I don't want to write out all those words. How do you know that is the next part, which you should be able to say it because we just did it, just talked about it. And then my third question is, can you find what number we actually multiplied by? So don't yell it out loud if you can find it, but there is a number that takes you by multiplication from 9 to 4.5, by multiplication from 4 to 2. Like there's a number that I'm multiplying each of these by that equals the new Y. Okay? So that's called the scale factor. And those are the three things you're going to do for the back questions. You're going to compare the ordered pairs, say why you thought it was vertical or horizontal, why you thought it was stretch or shrink, and what you think you're multiplying by. Okay? And then I'll have an answer key up soon. And if you guys ever have questions, you remember you can just send me a message. This will be due tomorrow. Got it? All right.